Again, we're about to balance a bunch of them, practice this a whole lot. You have to make sure that the atoms are the same on each side, that the identities of the compounds are the same. One common theme is someone will have water in a reaction, and they'll need to add one more oxygen because the other side is O2, but water is only H2O. And they want to change H2O into H2O2. They're not the same at all. Water is H2O. Does anyone know what H2O2 is? Hydrogen peroxide, yeah. H2O2 is hydrogen peroxide. Drastically different than water? So all of the compounds are based on the rules we were talking about when we learned about nomenclature. Like here, if we had aluminum and oxygen, I've got the charge for aluminum, the charge for oxygen. That's what determines the formula, the charges. So you can't adjust the formula because it's based upon the charges we're pulling off the periodic table. This is one thing people don't like, is occasionally they're not very easy and you just have to try them over and over and over again. You thought for some reason to put a 2 as a coefficient, but that's really not working. So try a 3. If that doesn't work, try a 4. This is definitely a chapter where a pencil would be the best choice. Pens can result in lots of scratching out. The steps, make sure that you have the equations right for the formulas. If you have a diatomic atom, make sure it's diatomic. We talked about diatomics a little while ago, so we said it could be Hofbrinkel or Brinkelhoff. So there are these 7 diatomics that anytime they're not in a compound, they have to be by themselves, then they're diatomic. But if they're in a compound, then they're just whatever they are in the compound. Like in this example here, hydrogen's by itself, it's reacting with oxygen by itself. After they react, it's making water. So they go from being diatomic as reactants to in products, they're water, and it's no longer by itself, so it follows a different set of rules. If you happen to have a ratio that could be reduced, make sure you do. So if you had like CX producing 3Y, what could you reduce that down to? You could divide them both by 3, and you'd have 2x producing just y. So anytime the coefficients can be reduced, please do so. Yes. And lastly, 2 basic hints. Sometimes when they're hard to deal with, you look for maybe an odd number of an element. Maybe there's only 1 oxygen, but on the other side there's 4 oxygens. Turn the odd numbers into even. What do you multiply an odd number by to get it even? 2. Multiply it by 2, you automatically got an even number of oxygen or whatever the element is. And then my general hint is balance oxygen last and hydrogen second to last. Deal with all the other elements first. And as we go through some examples, you'll see why that's a good idea. Oxygen last. All right, here's our first example. All right, Jay, it's you and me. All right, how many irons are on each side? And so that's okay, right? They're already balanced. What about the oxygens? And the lithiums? All right, so we need to add lithiums to which side? We need to add a lithium to the left side. So now that we have the same amount of everything? So when we go back to this equation, what do we need to write into it so that we have the right number of lithiums? We need to write a 2 before the Li, so we have twice as much lithium. Right? Now these are not attached together. There's 2 separate lithiums. They're not bonded. Like these are bonded or like that's bonded. There's 2 separate lithiums not attached together. All right. Who wants to do the next one? S. Yeah, there we go. All right. I already called on you. He gets to go next. All right. So this one's a lot more complicated, isn't it? All right. So you pick any element. We'll work our way through it. Which one do you want to go first? Zinc. So we have 1 zinc, 1 zinc. All right. So that one's good, right? All right. How about next? Chlorine. This one's going to be hard. This one's got 2 over here and 3 there. And the first instinct most people have, So we have 2 chlorines and 3 chlorines. My advice when you have 2 and 3 or something like that is look for the least common multiple. What's the least common multiple of 2 and 3? 6. So we cannot just bring a chlorine down and add it onto here. We need a whole another zinc chloride. Is that enough chlorines? No. So we need another zinc chloride. Because now we have 6 chlorines. What are we going to do over there? Another aluminum chloride. And I want to talk about why do there have to be 3 chlorines on this aluminum? It's the charges, right? Aluminum is a +3. And chlorine is a -1. So it takes 3 of these chlorines to balance out that positive charge. And then on the other side, zinc is a +2. Chlorine's a -1. So we can't just add one of these chlorines onto the zinc. It wouldn't balance the charge out. We need a whole nother set of zinc chloride. So that's sorted out the chlorine, but it caused some messes. What should we do? What do we need to fix now? The sulfur's not balanced. So what do I need to add? I need to add, but I can't just add S. I've got to add zinc sulfide and zinc sulfide. So now I've got 1, 2, 3 sulfurs here and 1, 2, 3 sulfurs. And the zincs, 1, 2, 3, 1, 2, 3. Aluminums, 1, 2, 1, 2. So now everything's balanced. So we're going to go back into that equation and balance it for me. What coefficients do I need to add? A 3 for the ZnCl2. Yep. You're going to leave this one blank. Yeah, it's because it's coefficient of 1, but we don't write 1s down. 3 here. And a 2. And it should work if we go through quickly. Just kind of go, okay, there are 3 zincs, 3 zincs. 3 times 2 is 6 chlorines. 2 times 3 is 6 chlorines. 2 aluminums, 2 aluminums, 3 sulfurs. 3 times sulfur, 3 sulfurs. That's the idea, is trying to make sure the 2 sides are balanced. Now this bubble thing here, that's not something we'll see on a test, but it's a good visual to kind of like actually see what's going around as it rearranges. Do you think that in the real world, you're actually only dealing with 3 zinc atoms? You're really dealing with like 3 million zinc atoms and 6 million chlorine atoms. This is the ratio of the reaction, though. It's the lowest ratio. So here are the answers. We have 3 carbons, so we multiplied that by 3. We had 8 hydrogens, we multiplied that by 4. Shh. The oxygens were tricky because they got split apart over here. We have 3 times 2 is 6 oxygens, and 4 times 1, so that's a total of 10 oxygens. And so here we did 5 times 2 to also give us 10 oxygens. And number 2, it wasn't too bad. We had 2 nitrogens plus 1, so we multiplied this by 3 to have the same number of nitrogens. And then the oxygens were 1 plus 2, again, the 3 still works for that. The third one was the hardest one. First we started off, we had 2 hydrogens, so we put a 2 here. They gave us 2 nitrogens, so we put a 2 there. Then we had to try to count up all those oxygens. We had 6 oxygens, so we said 6 equals these 4 plus that 1. And this needed to be 1/2 to get the 2 oxygens down to 1, but you're not allowed to have fractions. So we doubled everything up, 4, 4, 2, 1, to get rid of the fraction. And the next section, you have to actually write the equations first. Let's just go through and do this real fast. If it's a complicated formula like an organic compound, I will just give you the equation. Here's C2H5OH. Reacts with oxygen. What's the equation for oxygen? O2. Because it's all by itself, that means it's got to be one of those diatomics. What comes next up here? says reacts with oxygen to produce. So there's our arrow. CO2, that's carbon dioxide, yes. And what else? And water vapor, H2O. Yeah, let's throw the states of matter in here. Gas, 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 and this one's a liquid. I'm going to give you a couple seconds to balance this, but we're going to go on and write the other two down before we try to balance it. Number 2, what is the symbol for magnesium? Mg. And it's reacting with water. Water is H2O. To produce, there's our arrow. And then here we need to use our naming rules. Magnesium is reacted with hydroxide. What's the charge? What's the charge for magnesium? +2. And hydroxide? -1. So this is actually MgOH2. And the other product is hydrogen gas, which is one of those diatomics. And this is a solid, it says. This is water. And that's a solid. So we're going to come back and balance these in just a second. And the third one, nitrogen trihydride. What's nitrogen trihydride's formula? N. It says tri and then hydride. What do you think? NH3. Yep, NH3. It's usually called ammonia. And it reacts with, there's our plus sign, oxygen is O2 to produce. What is nitrogen monoxide? NO. Yeah, it's really a negative molecule. And the other one is water vapor. So here they are already balanced. You have to make sure that every element is accounted for. In number 3, you end up with a fraction. You end up with 2/2 oxygen. So we doubled everything to get rid of that fraction. Some of them are very easy. You just have to add one coefficient. Others, you have to go through several steps. In number 1, we had the oxygen split up, so we had to figure out how many total there were. Same thing in number 3, the oxygens were split up, so we had to kind of recombine them to figure out what to do there. That's the big advice. If an element is split apart, deal with it last and try to pick it up at the end. We're going to look at a couple of the homework problems. Worksheet 1 is your homework. Let's go ahead and pull that out and take a look at worksheet 1. And